All right, welcome back. So I hope you've all figured out how many different pins exist. Let me give you helpful advice though before we tell you how to do it. I want to tell you how not to do it. List out every single possible configuration. You could always do this. List out everything possible. 0000, that's a possible pin. 0001, 0002, 0003. And just keep going down until you hit 9998, 9999, and that will be all of your pins. Then you go back through and count all those numbers, and that number of numbers would be your number of configurations. It would take you forever. Well, what would feel like forever anyway, assuming you made no mistakes along the way or have left something out. So what you should do with this sort of thing is use, well, the only tool we've got so far, the fundamental counting principle, where you isolate independent events. Independent events, you isolate those and you multiply together the number of configurations for each independent event. So for this one, there are 4 independent events. That is because it's a 4-digit code. And each value that goes into each digit is independent of the other. You can use the same number every time. I wouldn't recommend it, but you could have 1111 be your pin. I need to go change my pen now that I've said that. You could have 1, 2, 3, 4. You could have anything. It could be in any order. They're independent of each other. So there's 4 spots. We're going to multiply together those numbers of configurations for each spot, and that product is our overall unique configuration count. So I'm putting 4 numbers here, multiplying them together. That might make sense to you. It might not make sense to you as to why I'm using 10 here, but you got to think about it. The numbers I could put in here are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's 10 different values. 1 through 9 is 9 numbers, but 0 is also something I could use. And in this case, 0 would count as a configuration. So each spot has 10 values. Multiply 10 to itself 4 times, I'm looking at 10,000 unique configurations. And maybe that's going to clue you in as to why you would not want to list out all the configurations by hand. One more example here, and then we'll start getting into permutations proper. How many 8-digit alphanumeric passwords exist? Now, just as a reminder, in case you never knew, when someone says alphanumeric, what they mean is anything that is a combination of letters and numbers, specifically lowercase letters, uppercase letters, or those numbers we just talked about, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those numbers there. So once again, we will probably crack this number counting problem using the fundamental counting principle, because that's literally the only thing we've got at our disposal so far. So I've got 8 digits, 8 places. I could, not that I would recommend it, have AAAA be a password, so I can repeat letters, I can have them in any order. So they are 8 independent spots. And here I'm multiplying in each spot the number 62. I picked 62 because there's 26 lowercase letters, 26 uppercase letters, A through Z, and the 10 numbers, as before. So altogether, first spot can be one of 62 things. The next spot can be one of 62 things. Next up is one of 62 all the way down. And so in all, we are looking at 62 to the 8th power, which, by the way, if you're doing something on WebAssign or even Pearson, I think, you might sometimes be able to get away with just typing 62 to the 8th. But if you do need the exact number, you can use a calculator, and that's what's hundreds, thousands, millions, billions, trillions, 218 trillion configurations. So remember, and we'll start getting the permutations next time, whenever you're using the fundamental counting principle, you can do it with impunity as long as the events are independent of each other, right? You can flip a coin 8 times, number of configurations, 2 to the 8th, heads or tails 8 times. Runners in a race, we'll see. I'll see you next video.